Alright, Mr. Hong here with another Algebra 2 video, and this will be the second to last video before our final exam before the end of the semester. So there's lots of things that we need to talk about in this section, or in this lesson, because we're going to be recalling ideas and topics from previous lessons. So today we should be learning about how we can find attributes of a square root function. And to do that, we have to understand that the square root function is an inverse. And we've seen this word right here before. The word inverse is talking about the opposite. And when I mean opposite, it's not like adding, or it's not like positive or negative. It's talking about like the opposite operation. As an opposite operation of adding is to subtracting, or multiplying is to dividing. So what is the opposite of square rooting? Which is this right here is unit 5. It's actually square rooting. And this is going to be what we're going to be talking about in Unit 6. So square root functions as an inverse is pretty simple because most of the rules that we learned in Algebra 2 in Unit 5 apply to Unit 6. So let's talk about it. My cursor, there it is. Alright, so to write the inverse function of f of x is equal to x squared, we have to first, make this into a regular equation. Instead of f of x, I'm going to write y, which is y is equal to x squared. Okay, the second step is to switch the x and the y. As in, I'm going to just switch literally this y for this x right here. And what happens is x is equal to y squared. So this x is now by itself, and this y is here with the squared. So now we have to solve for y, or we have to get the y by itself. So this becomes, this y, to get rid of a square, we proved, or we talked about it, is to square root. So if I'm going to square root, I'm going to rewrite this, x equals y squared. If I square root one side, I have to do it to the other. So square root of x is equal to y. Because these two things right here, if the opposites are together, applied on the same variable, they cancel. So this y, we just change it as f to the power of negative 1 x, or this is the inverse, is equal to square root of x. I cannot draw straight on this. There we go. So if you remember from like inverses from Unit 1, this is Unit 1. We just had that idea of like, okay, we need to first figure out what are opposites and how do we do it. So if I prove to you, this whole thing, this whole box, like step 1 through 4, is to prove to you that cubes or squares, squares are inverses of square root. So if I draw this function right here, x squared, it's going to look roughly, but not exactly like so. Like this, okay. So I'm going to draw it red, just so that we can see it better. It's going to look something like this. If I want to, I'll go like this. Never mind. It's going to look something like that. Sure, we're fine. So, is this a function? If I do the vertical line test, if I did a vertical line test like this, you see how these things only cross it like once, then once, then once, 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 and once. So this is a yes. Oh. But what about this? If I graph the inverse or the square root, remember how the graph, when we have to graph the inverse of stuff, we draw a table. So if I do x's and y's, this will now become, your y's become your x and your x becomes your y's, like this. So if it's like 0, 1, 2, let's do -1, -2, the y, or this table right here is going to be for this graph right here. 1 is to 1, 2 is to 4, this is still 1, and this is still 4. But what happens is that this area right here becomes here. So this is 0, 1, 2, -1, -2. This is 0, 1, 4, negative, or this is still positive 1, and 4. Because all I did was crisscross. This goes here, and this goes there. So if I try to graph that, okay, let's use the red marker again. 1, 1. Okay. 1, -1. And then it becomes 4, 2, 2, 4. Becomes like this. So if I connect the dots, it'll look something like this. Something generally like that. These are my points right here, which are 1, 2, 3, 4, 5. So 5 points. So if I did a vertical line test here, is this a function? Let me give you some time to do this. So I'm going to wave my hand for the Ed puzzle. Okay, so if we did the vertical line test, we go boop, 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 boop. So this right here crosses twice, 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 and so on and so on. All it takes is one time for the vertical line test to fail for it to not be a function. So this is not a function. So the title of this unit is square root functions. So if the inverse of x squared is not a function, then why does this matter? And a better question that we can ask is, what can we do to the graph of the quadratic function to make its inverse a function? What we can do is, if I go back into this graph, I'm going to erase some of the green. Just for educational purposes. You don't have to erase the green. But what if I just told you that instead of the red line, I just want... Why is it not switching? Hold on. Okay, I'm back and I fixed it, I hope. Okay, I did. So instead of me writing just half of my line, or all my line, what if I just said that I want to draw half of my line? Like so. What if I just wanted to draw this positive side like this? So I would graph something. I want to graph this right part. Where did my black line go? Yeah, something like this. And what happens is that I'm going to just graph x is greater than 0. Or you can write it like 0 to infinity. Instead of all real numbers, or instead of negative infinity to infinity. So instead of drawing every single possible outcome, what if I just limit my graph from the positive, just from the positive x value and so on? What happens is that when I go back to this graph right here, only this part of the graph is shown. And that's when we put into our calculator, which I'll do right now. If we go into our calculator and we go to y equals x to the... what if I just use this? Good. You can see that it only graphs one half of the graph. Because we just have to... We assume as mathematicians that we're gonna limit our domain for the quadratic to create a function for the square root. Because if the square root isn't a function, this whole unit's wasted. And that's why we're talking about that from day one. So in this bottom part, we answered it, but let me be more formal. What can we do to the graph of the quadratic function to make the inverse of the function? Make sure the inverse is a function. We can limit the domain. Of the quadratic x is greater than 0 or 0 to infinity. Nice. So I'm actually going to stop the video here because I don't want to make it too long. So I'll see you guys back in class. Toodaloo.